Hello and welcome to Hersley. I'm John McNamara and I'm here with David Radley. Hello, David.
Hi, John.
Hello, buddy. We've managed to capture Matthew Peters. It's a phenomenal project. Matthew, do you want to say who you are and what you do at IBM?
What am I doing at IBM?
What do you do at IBM?
Yeah, I've worked at IBM for forever, and I've been working in the on the Java virtual machine, IBM's Java virtual machine, for quite a long time. And right now, in the last year, I've been working on making the Java applications, giving them access to the GPU, graphics processing unit, if there's one in the machine.
That sounds phenomenal. So, is that the awesome project that you're working on most recently?
Absolutely. That's yeah, and me and several others over the last year.
So
it's just come out in Java 8.
Marvelous. Who else has been working on your team?
Keith Campbell is a guy over in Ottawa.
Yeah. And
Geeta Koblenz, who's in Toronto. So that's the the JVM team spreads throughout the world. Toronto and Ottawa, a lot of expertise.
Brilliant.
And a few other people here in Hersley. Adam and Chris get a mention, and Stacey.
Stacey one again?
Yeah, that's the one you know.
Yeah. Brilliant. Did I hang out with her on Bluedo a little while ago?
Okay.
Yeah. She promised me to not release it in public there. So, do you want to tell us a bit about your project?
Sure.
Just a high-level overview.
Okay. So the project is giving access to the GPU, the graphics processing unit from Java. Graphics processing unit is essentially a card that plugs into a machine that's got its own memory and it's got its own CPU. As the name suggests, graphics processing unit means that they're particularly optimized for doing graphics.
Okay.
And so that's, for example, shading every pixel in a scene, or applying a filter to every pixel in a scene or something. The thing that's characteristic about that is you're running the same algorithm against many pieces of data at the same time.
So like high-end gaming PCs might be using these sort of graphics.
High-end gaming PCs are always using these sort of graphics cards to render scenes. And in fact, most computers have got them in. Ordinary laptops have got NVIDIA, or IBM laptops have got NVIDIA.
And the high-end ones will be in the gaming PCs and laptops and the like.
Yeah, and the high-end ones are really chunky. The chunky things like the double-width card, big fan on for cooling, because they're as powerful in their own way as the CPU.
Yeah.
But they're specialized for these particular sorts of tasks. Do the same thing to lots of things at once. But they're not just for graphics, because sometimes
the main might think it was just for graphics.
The G in GPU might make you think it was just for graphics, and once upon a time that was true. But then some people came up with the idea of what they call GPU, general purpose GPU programming, which is the idea that you use it for something which has nothing to do with graphics, but for I don't know, analytics or modeling or simulation or anything which is arithmetically intense and fits the particular style of, I've got one thing that I want to do against lots of pieces of data all at once.
So it's an extra resource that the computer could use for that type of computing.
Yeah, you might call it an attached processor or something like that.
Yes, yeah. Have you got an example that you might want to share with us that might be that we could relate to about how you might use this?
Well, they're really. If I look at the set of applications that use the GPU for this kind of performance, it's essentially you use it for performance.
Okay. Yeah.
There's an awful lot of it in the scientific and technical world because performance really matters. So modeling and simulation and I don't know, weather forecasting.
So involved with research and the like must be involved with it, I guess.
There's lots of universities, but lots of companies that do that kind of work as well. Because there's an awful lot of what you might call real world problems, physical modeling problems that work really well on this kind of hardware. It's something to do with about the fact that the problem space divides itself up. So, for example, if you're doing weather forecasting, you might each CPU gets to do a little area.
Yes, yeah.
And then the areas communicate with each other, such like.
And the GPU could be involved in that.
That's the sort of problem the GPU is really good at.
Okay.
It's a style of program that they used to call, well, they still do actually, called SIMD, Single Instruction Multiple Data. And that's a style of programming that's been around since parallel processors.
So this is all about parallel processors, the single instruction being across lots of different data.
It's a particular model, a particular style of parallel processing.
Yeah.
And it's been researched and investigated for many tens of years. 20, 30 years ago, we would have called the vector processors.
Okay.
It's the same thing in a new package.
And now in the Java world, I guess is the big thing.
Well, what we're doing now is in Java 7.1 and in Java 8, making it possible for a Java application to use the GPU.
Yeah.
At the moment, the language of choice for using the GPU tends to be C and C++.
Yes, yeah.
But if you've actually already got the data in the Java heap, or you want to integrate with an application that's already written in Java, or perhaps you just like Java more than you like C or C++, until now, if you really wanted to use the GPU, you had to write a lot of quite difficult Java to C interface code, JNI code.
Yes.
And that's quite a substantial hurdle. So what we've done in Java 7.1 and in Java 8 in the IBM JVM is make it possible for this, I should say, also currently for Power 8 little endian machines only.
Okay. What's little endian again?
You want to know what little endian is? It's where the bits in the word go in this direction rather than that direction.
Okay.
There's a big initiative in the power hardware world to move to little endian, because that makes it so much easier to integrate with cards and devices and software.
And this is 64-bit?
This is all 64-bit.
This is all 64-bit?
Yeah.
64-bit little endian.
64-bit.
That's the words we need to know, is it?
That's the machines that. So IBM's announced as part of the Open Power Foundation.
Yeah.
Two of the partners in there are IBM and NVIDIA. NVIDIA, the makers of GPU cards. One of the models of the recently announced Power 8 Little Endian has got one or two of NVIDIA's Tesla K40 cards in, and they are really very powerful parallel processors in their own right. So,
and that's the hardware setup you'd need to use in order to work with for Java to use the GPUs.
Correct. Yes, that's right.
Okay. Oops.
So
if I wanted to play around with this and get my hands on it and learn more about it, how could I?
Well, you do need access to a Power 8 Little Endian 64-bit with the bits with Java 7.1, IBM's Java 7.1, or IBM's Java 8 installed. We're currently writing up some developer works articles that will go out quite soon, just to explain what we've been doing, and we've actually done 3 different things to the JVM to do with access to the GPU. Just very briefly, they are an API to the GPU called CUDA for J.
Yeah.
CUDA is NVIDIA's toolkit for reaching the GPU, and it's a C and C++ based toolkit. And CUDA for J, as you might guess, is a Java API to the GPU that's natural and expressive in Java. So it uses exceptions in the right place, and the APIs look natural from use within Java. But still, in order to, and they take away almost all of the ugly interface code. So you write almost everything in Java. You still have to write the little arithmetical kernel in C at the moment. We've put some stuff in the class library. So just within the class library, if the GPU's there and this particular instruction is going to go faster, it'll just under the covers go to the GPU. And the third thing is In Java 8 only, there's something new called lambdas, which is to do with little blocks of executable code being first-class objects, really. And there are certain idioms in the use of Java. For example, you might go int stream, parallel, for each element in the int stream, do the following. And that's something that the just-in-time compiler within the JVM can recognize and go, that's an opportunity for parallelism. I can do that in parallel on the GPU.
Right, okay.
So those are the three things you put in.
A new word, that's a new keyword within Java 8, is it?
It's a new keyword that looks that it's all part of the whole paradigm or idiom to do with lambdas. Take a stream and in parallel do something for each of them.
So it's a hint to say if you can do this in parallel, go ahead.
Yeah. And if there's no GPU, and it'll do it in parallel using CPU threads. If there's a GPU and the circumstances are right, here's an opportunity to run faster. Do that with the GPU.
Yeah.
So those three things: Good4j, parallelize and sort within the class library, and lambda expressions. Those are the three things we put into the JVM recently. And if people, so I'm kind of coming back to your question, if people want to try that.
Yeah.
So we'll be writing up developer works articles, which are all about how to use these things.
Yeah.
And the performance benefits that you see when you do. At the same time, at next month's GTC 2015, GTC is NVIDIA's big yearly tech conference. I'm giving a hands-on lab where somebody can come along with a laptop and they can try it out for themselves.
Fantastic. And when's that on?
Oh gosh, week beginning 17th of March.
Brilliant.
Where is it held this year?
San Jose.
Wow.
So
How you must
take me to
suffer.
the sunshine. 66 degrees, 18 degrees Celsius average temperature this time of year.
Very good.
Great.
And there's a lot of people wanting to know about GPUs there.
There are 500 sessions. It's absolutely massive.
Wow.
Wow. There's a lot of appetite for people out there wanting to know, and a lot of expertise out there already in the GPU space, I'm guessing.
It's a surprisingly big world, actually.
Yeah.
You're right. There's a lot of appetite because the speed up for the right sort of algorithm.
Yeah.
The speed up can be immense. That you can for just the right. If you hit the sweet spot, things you can see speed up of more than 100 times, 200 times, 300 times, 400 times.
Nice.
And so this is very interesting. It's a whole new world, really. And as we start to see more use of arithmetically intense work in the commercial world with a lot of analytics and such like, it's a real opportunity.
You can see machine learning and the like is very much in this space.
Exactly so.
Yeah.
Fantastic. I'll put details in the video so everyone knows where to come and talk to you and
Thank you.
and get their hands on the goodies, and also I'll update it. We've got details on the DevWorks articles too.
Thank you.
Matthew, thank you very much, buddy. David, always a pleasure.
Thank you.
It's been great to talk to you.
And yourself, take care. Bye, everyone.
Take care.
Bye.